Bienvenidos, Ushamdid, and welcome University of Maryland Global Campus learners from the CMIT-456 Section 6380 course for the Fall 2021 semester. This is the CCNP ENARSI version 8 course curriculum, and in this activity we're going to be taking a look at Packet Tracer 11.2.1, where we're going to configure and verify external or eBGP. All right, so let's dive into this activity, and full transparency here, this is an activity that used to exist in the 4th CCNA course under version 6. So not the current CCNA version, which is version 7, but under the previous version, version 6, this was in the Connecting Networks course. And this activity is a good activity for a CCNA level. However, I'm going to be placing additional links to videos that I've created in the past that go much deeper into BGP, iBGP, and eBGP that are a little more CCNP level and appropriate. All right, but let's go ahead. Let's dive into this activity here, and let's take a look at what we've got going on. We have our addressing table over here, and we're going to configure eBGP in the Acme network right now for part 1, and then we're going to go out to other company network. And so you can see we have our autonomous system numbers here, and these are 65,001, 003, and 002. Now, the first thing it wants us to do is configure eBGP in Acme Incorporated. And from the ISP entry 1, we're going to be doing some quick validation here. And you can see it looks like some BGP neighbor adjacency activity has been taking place on serial links. And they say from ISP1, verify the ISP has provided reachability through its network by pinging 1.1.1.9, which is the address of ISP entry 2. And however, I think they're going to want us to do that from the Acme border router, but we'll leave ISP entry up because we're going to need that as well. So let's go ahead and stretch this out here. And let's actually see if I say show IP BGP, you can see there's no IP BGP, or there's no BGP information. If I was to say neighbors, there is no neighbor relationship. And so let's go ahead and run the ping from here, because it's not going to work from router Acme 1. However, from ISP entry 1, we do have connectivity to ISP entry to the serial 000 interface. From any device inside the Acme network, ping the other company server. Now, there is definitely no way, and we'll do this off of PC0, there's no way that this should work because, and I'll walk you through this step by step here in just a second, if I was to say ping 172.16.10.2, we're going to see destination host unreachable. And who's giving us that message? Well, it's the 192.168.0.1. So what's happening is PC0, and actually we'll step back to PC0. So PC0 executes this ping command saying, take me to this other network, 172.16.10. If we look at the configuration here, you can see that it's learning everything via DHCP from a DHCP server. And the default gateway, which is where it's going to send, which is where PC0 is going to send the traffic for which it does not have a longer, more specific match or route to get to, it's going to send that traffic to its default gateway. Well, it just so happens, if we look at the Acme network here, that there's really only one candidate here for the default gateway. 192.168.0.1 just happens to be the IP address on the inside interface on the Acme 1 router. So this is the default gateway to whom all of these devices will be sending traffic for networks they don't have routes for. And so laptop 1, laptop 0, and PC 0, if they're all trying to get out here to server 0, which is the 172.16.10.2, that traffic is going to come to Acme 1 here, their border router, their default gateway. And what they're going to get back when they try to get there is destination host unreachable. And the reason that they get that is when I say show IP show IP route, there is no gateway of last resort set here, and there's no longer more specific match in the routing table. You can see that there is no route to the 172.16.10. And therefore, router Acme 1 will reply back to any pings that try to get to that 172.16.10 by saying, hey, I don't know how to get there, destination host unreachable. All right, so now we're going to configure Acme 1 to become an eBGP peer with ISP entry 1. Acme has an AS number of 65001 and the ISP is using 65003. So we're going to use 1111 as the neighbor IP address and add the Acme internal network to BGP. So how do we do that? Well, configuring BGP is really very easy. It's the policy application with BGP that can become very complicated. So we're going to say show run section router BGP. Let's make sure that there is no BGP section configured yet. And as you can see, there is not, because remember, we can only have one. If I tried to create a second one, it would come up and say, hey, the autonomous system number, whatever the first one was, that already exists. So let's get into global config and let's say router BGP 65001. And let me double check that. Yep. All right, so what are the options that we have here? Well, we've got some BGP specific commands. Well, let's go ahead and let's log neighbor changes. We could even set the BGP, we could set the BGP router ID. And, usually you want to pick something conspicuous that would help you identify this router. Again, we don't have a whole lot to choose from here, so what we could do is just simply go, and I think it was 1.1.1.2, so we could say 1.1.1.2. And that's going to be our BGP router ID. Again, we're not getting any points for that, but that's okay. So it wants us to go ahead and set up the adjacency with the neighbor, right? And you'll notice there is a neighbor command under the BGP global configuration stanza. So, So I'm simply going to say neighbor 1.1.1.1. And if we do a question mark here, you can see we have a next hop self, which we would not use in this instance. And then we have remote AS because we need to determine, right, or define, if you will, whether this is going to be an iBGP, an internal BGP peering, meaning it has the same autonomous system number that we're using, in this case 65001, or is it an external eBGP peer, which means the autonomous system number would be different, which it is, in this case 65003. And therefore, this is going to be an external BGP peering, not an internal BGP peering, right? And so you can see now the neighbor adjacency is up. So now let's go ahead and let's save our config and let's say show IP BGP. And we can see that we've received some routing information here. We know about the 1.1.1.4/30 network. We know about the 1.1.1.8/30 network. And these little codes over here are very important. This asterisk means something, and the greater than sign means something. The asterisk means that it's valid. And valid meaning I can get to the next hop, which is a BGP well-known mandatory path attribute, meaning update messages with routing information must have the next hop value defined. Because if the next hop wasn't defined or it's not reachable, this asterisk would not be there. So they all have the asterisk. These three routes, These three routes all have the asterisk because the next hop, 1.1.1.1, we are directly connected to that. Remember, that is the serial interface IP on ISP entry 1. So therefore, the next hop is valid. And if it is valid and we can reach it, we have an asterisk next to the route. Now, you'll notice something different between the first and these bottom two routes. The bottom two routes have the greater than sign, indicating that this is the best route to get there. And this is the case. And so for 1114 and 1118, it's not only valid because the next hop is reachable, it is the best path to go. And if you look at this here, it's a straight line. It's not like we have, any routers, any real choices that need to be made. It's not like there's a router out here that then connects to a router over here that maybe then connects down to this router here or this router here, right? We've got sort of this straight line here. And so it's going to be really easy to say that, yes, this is going to be the best path. And the best path selection criteria, which we will get into, is not so much complicated as it is just very, very intricate in terms of the decision process that BGP makes. BGP is really not that interested in cost. And as I say cost, what I really mean there is speed of interfaces. BGP is really interested in the AS path length. How many autonomous systems do I have to pass through to get to the destination? And that's really sort of the first criteria that BGP will be looking at when it's determining which of two or more routes is the best. So back to the greater than sign down here. So we have the greater than signs here, but we don't have it here. And this often comes up where learners will see that and say, well, wait a minute, that doesn't make any sense because we can also get to this network. Now, let me show you the show IP route one more time. Why do you think that the BGP learned route here is not better than the directly connected? Exactly, because it's directly connected, right? And so that's why we don't have best, because it's not the best. It's not the most trustworthy based on administrative distance, right? The administrative distance here on a directly connected is much lower than an eBGP learned route, directly connected being 1 and the eBGP being 20, right? So it's more trustworthy because we are directly connected. So that is not going to be installed. This one here will not be installed into the routing table as a BGP learned prefix. It's going to be the directly connected prefix. And so then let's go ahead and continue on here. So from any device inside the Acme network, ping the other internal server. Again, does it work? In the answer, if I was to say, and we just said show IP route, do you see something for the 172 in here? You do not. So let's pull the PC back up. Let's re-execute the ping to see that the Acme 1 router is going to tell us the exact same thing. Destination host unreachable. I'm getting traffic, says the Acme 1 router. I have no clue how to get there because I don't have a route in my routing table that is a specific match, and I have no default route or no gateway of last resort set. And the reason for that is because we've got to configure the other company eBGP peering, and we're going to do that right now. So we're going to configure other company 1, which is other company's router here. And we're going to configure this for an eBGP peering. Oh, and wait, there was one thing we forgot to do. I'm sorry. And we're going to add the Acme network. I forgot to do that. And if we didn't do that, what would happen is that router BGP 65001 is our traffic might get over to other company, but it will never find its way back because we have to advertise our network so that it goes out and it gets advertised via BGP. So we need a network statement. Now, here's what's interesting with the network statements. For this 192.168.0.0, now there's a mask option here for non-classful statements, network statements that we put under the BGP config, we don't need to say mask 255, 255, 255, 0, because it is implied that it is a /24. So in other words, if I leave all of that out, BGP is going to assume, oh, it's a /24 because that's what a 192.168.0 would classfully be, is a /24. Now, not a bad idea to put it in here, but let's see what iOS does when I say do show run section router BGP. It removes it, right? So might not be a bad idea to drop it in there. However, it's not going to get put in there. So do you need to put that in there? No. When it's classful, right? If it was a 10, I don't need to put in 255.0.0.0, right? If it's a 172.16, I don't need to put the 255.255.0.0, right? The RFC 1918 space there. So again, I wouldn't need it for this RFC 1918. I wouldn't need it for the other RFC as long as they are being used in a classful fashion. Now, when that is not the case, like let's say there's a loopback address that's a /32 on here that we want to advertise, then we would have to put the mask. And if you don't have the correct mask set for the network in question, the route in question, the NLRI, the network layer reachability information, BGP is not going to advertise it. In fact, let's do that. And so again, we're not going to get points for this, but hopefully Packet Tracer is going to cooperate here. So now I'm going to add a network statement in for the 209.165.99.0, right? Or we'll do .99. This is going to be a /32, but I'm going to go ahead and say, well, it's part of a /24 network. So that should work, right? And we'll see if this works. I'm going to go into interface loopback 209. I'm going to say IP address 209.165.99.99. And we're going to do an all 255s here. And there we go. So I've got those two networks defined. Let's save our config. Let's go ahead and confirm that. Show run section router BGP. And you can see the 209 is a /, it's in that 24 range, which is why on the network statement here, we don't see the mask out here, right? And so let's go ahead and take this to its scenario to its completion here, and let's pop over to the other company. We'll go from user exec to privilege exec into global config. We're going to say router BGP 65002. Sorry, 2. Got to be careful there. 65002. And we're going to go ahead and say BGP Log Neighbor Changes. We're going to set our BGP router ID to our interface, and let's do this do show IP interface brief. And so we'll set it to the 11110. So BGP router ID 1.1.1.10, and we'll go ahead and then say the network, well, actually, well, not the network first. We'll do our neighbor first. So neighbor is going to be, what do they want? 1.1.1.9, 1.1.1.9. And what is their remote autonomous system? Because it's this statement. It is this statement right here, the neighbor statement, that is going to determine whether this is an iBGP or an eBGP peering. And the remote AS is 65003, meaning it will be an eBGP peering. That eBGP peering is now up. And now here's the thing. Let's go ahead before we advertise the other company network. Let's say do show IP BGP. And lo and behold, we are learning the /24 network from the Acme network. Here's that 192.168.0.0/24. But do you also notice what network we are not learning? Yeah, where's that loopback address? And that was my point. If the network you are advertising does not have the correct network mask under the BGP configuration section, BGP is not going to say, oh, well, that IP address, well, that would fall under the /24, so let's advertise it anyway. No, that is not what BGP is going to do. BGP is going to say, well, It's configured as a /32. You're trying to advertise it as a 24. We're not advertising that. Sorry, not going to work. Not going to happen. So let's do this. Let's come back over here to Acme and let's get into global config and let's get into router BGP 65001 and let's say no network 209.165.99.0. Sorry, .99. I can't remember if I said that or not. And so let's say do show run section router BGP. Make sure it's out of there. So now what happens if I say network 209.165.99.99 and we put the mask on here that matches the actual configured subnet mask of that network. And now you see that it leaves the mask statement in here. So if it's classful, it's not going to put it there if it matches that network statement as being classful. When it's not classful, it will leave the mask statement in here. And a lot of learners, when they see this behavior, they think that either they did the mask wrong or that something else is wrong, right? That's not the case. If it is a classful network that you're advertising, even if you put the mask statement in there, iOS is going to pull that out because it recognizes, hey, this is a classful advertisement. When it is not, it will leave the mask portion of the network statement under the BGP global config present so that you could look at this and say, oh, right. Yeah, that's right. This is /32. And now, I hope we waited long enough and we did, right? There it is. And so that proves that BGP is not going to advertise a network just because it falls underneath a larger supernet that might be being advertised, right? If it's a longer, more specific host route like this, right, as an example. Okay, so we've got that in there. We've got the 192.168. If I came back to Acme, right, we should also be seeing, we could say show IP route to see any BGP learns routing information. Show IP BGP shows me the BGP routing table, showing me that, hey, I am oh, wait. That's right. We haven't actually advertised the 172. I was looking here for the 172. We didn't see it because, yes, once again, I forgot to say 172.16.10. And this is another great conversation piece, right? If I hit enter right now, it's going to take this. It's going to think it's a /16, which is why we have to say mask 255.255.255.0 because it's a 172.16 that's been subnetted, right? So now when I say do show run section router BGP, we see that the mask portion of the network statement under the BGP global config remains because we have subnetted that. So now we'll come back over here and we're going to say show IP BGP. And we should have a 172.16.10, and we do. It's best. It's valid, right? Asterisk for valid, meaning I can get to the next hop. And best because that's the BGP best path selection algorithm saying this is the best path. This is the shortest path for me to get there, right? So now we say show IP route. Did it get installed in the routing table? It did. So now when traffic comes from PC0, trying to get to the 172.16.10. And the PC says, hey, I don't know what to do with this traffic. I'm going to send it to the default gateway Acme 1. Acme 1 gets it and says, hey, do I have a longer, more specific route? Or do I have any route to get there, right? And lo and behold, here it is. And what does it say? Via 1.1.1.1. So I'm sending any traffic for the 172.16.10, and there's that administrative distance for eBGP learn routing information of 20. So where am I going with that traffic? Who am I sending it to? Well, I'm going to send it to 1111, who's my directly connected neighbor, ISP entry 1. It's going to get over here, and then the return traffic is going to come back through other company 1's router, and other company 1's router is going to say, well, hey, the destination IP is this 192.168.0 IP. Do I have a route to get there? And yes, I do, and it was learned via eBGP, administrative distance of 20. And, sorry, I didn't want to grab the 209. And where do I send it? To the 1119, who is my directly connected eBGP speaker. So you can see that we're at 100% right now. And again, this is a nice soft landing activity. However, I've got additional links down below in the description of this video for other more advanced BGP scenarios that are going to get into the semantics that you're going to need to know for iBGP and next hop self, as well as other eBGP specific information. All right. As always, thank you so much for watching. That's going to do it for this Packet Tracer activity 11.2.1 on configuring and verifying eBGP. Thanks so much for watching, and I hope to see you in the next video.